Hey guys, welcome back to the Mini Machine Shop. I'm Dave, and I have no clue what's going on. Like I said before, I download all the video from the camera, put it in the editor, and then I come back and I shoot the intro. I'm looking at this video. There's a whole bunch of video there that I haven't published. I don't think. I'm looking at all the videos they did publish. I don't see this stuff in there, so I'm wondering, what in the world? And then there's video that I know I shot, and I can't find it. So I guess I'm just going to let it all go. Not a whole lot going on in the shop. I did some rearranging here. I'm running out of room. The drawers are getting full. So I put all the clamps out there so I've got more room in the drawer for toys and stuff like that. Same way the whole collet set was just too heavy for this drawer. I didn't design this. This was more like a desk drawer. It's not able to hold that heavy weight, and so the drawer was starting to break. I had to fix it. So now I just have the collets up there, and I have no clue where to put them. But okay. As far as video, I just wanted to show a little clip, right? The Spindecks first, yeah. Little clip on the Spindecks and what I've been doing. Thought I'd just show a close-up of the Spindecks are here. What I was waiting for was the 5C collet. The first one that I ordered from Amazon was oversized. It was supposed to be 1 inch and it was 1.45, something like that. So I returned that one and I ordered another one from another manufacturer. And this one just arrived today, and yeah, it's 0.995 or something like that, so it's perfect. It clamped down. I can't turn this. It was turning in the other one, so this is really nice. I can put all the ER32s in there, and the pin I'm keeping 8. Hard to explain, but I like it to line up on 0. This thing is heavy. Where's 0? Right there. To put the arrow right on the 0, I have to put the pin in number 8, so I just leave it in 8. I don't know why. This doesn't really rotate, it's keyed, so it has to be that position. But all you do is you just pull this out. It's a real snug fit. You rotate it to whatever degree you want, push the pin in there, and it stays on that dimension. So I'll just leave this guy in here. Now I can use everything. So that's it. Indexer, Spindexer. Alright, up next, I was watching another video on YouTube with dial indicators and how much pressure the plunger puts on things. So I shot a little video of it playing with my dial indicators, and because of where it was, I couldn't read the numbers that were on there, the angle. There was all kinds of glare and stuff. I did it more for the camera, and it looks like it keeps reading 0.8 when it should have been zeroed out, but it looks like it worked anyway. It was given the correct numbers, so I don't know what that's about. I'm going to shoot this because I thought this was rather interesting. I was watching a YouTube video, some guy testing how much force the spring inside of the dial indicators do. He was pushing on the scale with something like, what, $150, 80, what, something crazy, stare it, and came up with 3 ounces. But I was looking at this, wondering myself what's gonna, if you just push slightly on it, I can't read it. What is it? Oh, 4. I'm looking in the camera to read it. 4 ounces, 5. If I push all the way down, 6, 6.5 or something like that. That's not really that big a deal to me, that much force. Try my little guy, because I never really go all the way down with it. I'm just indicating run out and stuff, so big deal. Here's the little guy. Let's see what he's gonna do. You just barely push. I gotta just pay attention so I don't. Alright, there, I'm just barely pushing. and now I'm just about all the way down, so I don't know what the readings are. I just had to concentrate on what I was doing. Okay, that doesn't go in there that way. But just kind of curious, you know, playing with it by hand, it doesn't feel like it's much force at all. But I was looking for something to see what the weight is. Yeah, see, that's 6 ounces, and that's pretty heavy. That feels like that's quite a bit of force that's pushing. Which would, if you did have something in the vise and you were pushing on it and it's thin and long out, then yeah, you're going to be bending it, so you're going to get the wrong reading, but not really with anything that I'm doing. I don't think there's any other, yeah, I don't want to do the test indicators because they're flyweight, so. Alright, just thought people would be interested in seeing that. Alright, and playing with that force, I just wanted to see if, yeah, you can, whoa, you can bend that. You can see it bend. Oh, you're not going to be able to see the dial. Well, I can, get that loose. Put it down here. There. Tighten that up. Wow. Actually, you're not moving it that much. I'm pushing pretty hard. Let me get that dial indicator back out and push down. Alright. I'm going almost all over. Yeah, just, no, I think it was barely moving. I tried to keep it on there. I'm almost pushed down all the way. If I come out in the middle, oh yeah, it's just contact right there, it moves. Half a thou. Pushing down, pushing down. So that's about 6 ounces of pressure, and that moved it a few thousandths. So, I know that when you're trying to turn out here, you better have a center on it, because it's going to flex on you. Either that or you got to run back and forth a bazillion times until you finally cut all the material. So, pretty interesting. And that's, oh, this is a 3/8 aluminum rod. Steel's probably going to be tougher, but I wonder. Yeah. Alright, well, curious. Alright, this next clip is the first controller that I bought, showing that it's not really a very good controller. Alright, walk around for a second, give you an update on trying to put a power feed on the mini mill. There's a variable power supply, and this is a $10 motor controller from Amazon. It says it's pulse width modulation. There's a simple motor that I've had kicking around. It's 100-to-1 gear ratio. So, and here is it on the screen. I don't know if everybody can see that. So, but let me set something up here. Alright, I know a lot of people don't have a $8,000 scope, but I just wanted you to see this. You can Google what pulse width modulation is supposed to look like. That isn't it. It's close, but it isn't it. And the problem is, if I grab the motor, I can almost stall it out. I could probably, yep, I just stalled it. So, this is not a good motor controller. It does somewhat do pulse width modulation, but not all the way. And the kick is, if I just put the power supply that you saw earlier here, the variable power supply on the motor, you cannot stall it. I can go down to 1.5 volts and grab the spindle, and I cannot stall it. So I'm thinking I'm just going to do some kind of variable power supply and return this thing. So after I discovered that the controller wasn't that hot, I went back on Amazon and looked around and found one that looked a lot better. So I ordered it, got it in, and here's my testing of it. Just got another controller. This was the original motor controller, and this was $10, but it's not pulse width modulation. this guy is. I can tell right off the bat. Look at that. And it's hard to stall that motor out, even at a low RPM. Yeah, I can do it, but it's a lot harder going up in the RPM. That's percentage, not RPM. Yeah, that's, you ain't stalling that. You can hear it too, man. The motor starts jerking around when you get higher. Seems like it starts vibrating on the table and moving. There's 100%, 12 volts. It's pulling more amperage too, 80 milliamps it's pulling. 60 milliamps. And 30 doing nothing. So, wow. Crank the voltage, take it up to 13. And still stop the motor. 13. Wow, that's nice. So, this is going to be the controller I'm going to use. Wish that lit up though. I think in their picture that did light, but so this is pretty cool. I like this guy. This was $18 with free shipping. Alright, so the rest of this video is going to be making a diamond surface grinder, whatever you want to call it. Like I said, the drill doctor, that was another video piece that I lost somehow. I had said that I wore out the diamond wheel on the drill doctor, ordered another one from Amazon, got it in, put it in there. It's still not sharpening bits quite right, so I don't know what gives with that, but I had this extra wheel. So I'm going to make a grinding arbor and grind steel and see what happens. So the rest of this video is grinding. Well, I have no idea how well this is going to work, but since I've got it, make a surface grinder. I'm thinking make something like this to hold it. That'll be a little bit thinner. And I was thinking keep this thicker for it more rigidity, but it doesn't matter. So this, I didn't care. I just turned these things because I was always using the chuck and it could mount anything. So this wound up being 12 millimeter, which is just a little too small for a 1/2 inch chuck. But so, and I'm thinking for this guy, start with 3/4, because 3/4 just kind of sits on there right. And I can spin it down a little bit, make a shelf like I did in this, because this looks like it's really precision cut. Oh, that's dirty, nice. This is really precision inside and smooth, so I'll have to try to hit that right on the money so it just gets snug. Probably doesn't matter too much because there's going to be run out in the collet, but let's mount it up and see what I can do. Alright, faced it off, and I can't tell you how many times I've used this saddle stop. It's just constantly in there. Alright, let's get this guy in here. It's got to go the other way. Right? Turn around 180 degrees. Now try it. Still wrong. Turn the whole thing around. There. Get in there. There it is. Alright, so I want to cut. Oops, I don't like that. I want to cut it to that depth. Right there. Tighten that down. There we go. Right. Making 10,000 cuts with the auto feed. A little bit of 89. closer to ½ inch. I swear that thing wasn't anything near a ½ inch. By the time I calibrated, I was already underneath. So it's what, 15-30 seconds, call it, and I just spun it down to, yeah, chips everywhere. That's why I had the auto feed, man. I spit chips all over me. Alright, so that goes down. Just need to bevel the edge, clean this guy up. Jeez, wait, juice all over it. Underneath, on top. By the way, this finish is hasn't been touched. It's just right off the cutter. So it's pretty nice finish, I guess. I'll probably clean it up anyway. So put this guy in there. These are the new 3/8 sets. I want more of an angle than that. Well, it looks like about a 45. And go real slow. That's pretty good. Is it nice and smooth? Yeah. Not really. Angle it some more. Come in. That should do it, right? Yep, perfect. Nice and smooth. Alright, need this guy. Need the finer stuff. That looks pretty good. Nice. I gotta bevel the other edge too. At it. Bring it out a little faster than that, Dave. Back it out more. There we go. Well, I got it in there. That's pretty good. Alright, now I just do finish the length of this. What? Yeah, about the same length. And then take it over and hacksaw it off rather than using the parting tool. I think everybody's seen me part before. I realize I do have to, can't just use a hacksaw, because I gotta face that off and get it all clean. And then I'll turn this around to make the bottom piece. But it just goes right in. Yep, it does get hot, so you gotta use cutting fluid. It never fails whenever I do this. I always forget to tighten up the tool holder for the cutting tool. Alright, well, this is boring for you guys. There it is, right on it now. Scary when you're trying to get it that tight. It just sits on there, perfectly centered. So it's just a little bit of cleanup here. Break sharp edges a little bit. Wow, I need a magnifying glass for this. Make sure I don't go too far. Alright, so bring that over. I gotta go in there more. There we go. That should do it. Alright, that ends its clean. Chuck. That'd be done. Now I just make the bottom part. Alright, show a little tapping here. Where is my favorite stuff? Tap magic. Love that stuff, huh? Oh, yeah. Put a little on the tap too, why not? Stick it in there, push, and feed it in. Oh, I see a whole bunch of chips coming out. Because I want this straight. Alright, I think that's far enough. Undo the chuck. Pull that, and I can actually put that away now. Pull that off. Put that away, the chuck away. Where's my little crescent? Right here. Get it out, blow all the chips off of it, run it back in there again. Use reverse save. Much faster. Yuck, lots of junk on it. Air, there it is. Alright, a little more tap magic. Just a drop of it, a little dab will do ya. Alright, get in there. Get started. There you go. There you go. Almost. Wrench. I'm still trying a little bit by hand. Go until I find the bottom. Give me a kick. I'm going to turn this on and see if it wobbles. Hopefully it doesn't. I went that far in. A screw that I'm not going to use. Oh, this is a 1024 tap. That's the screw that I used on the other arbors. And I got that fancy little stainless screw from Fastenal. This is probably far enough. Let's see if it wobbles. Yeah, it wobbles. Well, I don't know, but it does. Alright, reverse. Go. Alright, done. Done deal. Drilled and tapped. Yeah, just as far as aesthetics, what looks best is tops, if you bevel them a lot, and then the bottom just barely touch the edge. Just break the sharp edge is all. Like that. And it kind of looks right. I think I should have beveled that even more. Yeah, I might put it back in there and bevel it a little bit more. Fun part for those interested, this is the, if I can get it in there, that's the screw that I had bought. And so we're going to do a little countersinking here. So this thing sits flat. Alright. That does not look on center for some reason. Why is this thing so... Can't be that far off. Can't tell. I don't want to mess it up either. That just does not look right. And yet when I did the drill bit, it's on center, right? Take this out. Put a drill bit back into it. What did I do? Any drill bit. 187. So otherwise, I just do this with the mill and use the edge finder. Yeah, it's on center. Alright, I guess go for it. Otherwise I have to remake it. Let's get the cutter back in there. tighten that guy down. Slide it forward. Lock that down. Let's go. That's how deep I am. Oh, that's close. No, I gotta go quite a bit further. That's close. Where's the screw? There it is. Back this guy away. Stick it in there. Bingo. Wow, that's a bigger hole than I thought. I did too big a hole. Oh well. It'll work. Now at the end here, the last piece, I did take a piece of steel, put it in the mill, and tried grinding it was steel rod, I was just trying to finish off the edge of it, and looked at it and said, it's a total mess, so this is not a good surface grinder. Oh well. But I did later on think of another way to apply it, and so here's a clip on that. Alright, show and tell time. Put a piece of paper here, that way I know if I'm on the paper I'm still in the view. This guy, I did put a shoulder on it so it sunk it further in, and I guess you saw that it doesn't doesn't do much, but later on I did. Where is it? Oh, here it is. I did take one of the old Harbor Freight carbide guys, and you can see it cleans that up really nice. Am I in? Well, where? This way. I don't know if you can tell, but that's, you know, I put this in the mill, put this on the mini pallet at 30 degrees and just ran over it. Gave me a nice point, and I've been dying to find a threading tool that's inexpensive. I still have to finish this side of it, but it cuts pretty nice, so I should be able to use this to do the other side, and then I've got a threading tool that I can try out. But it's kind of cool. So if you guys want the diamond thing, just go and buy a drill doctor and make your own arbor here to hold it. Alright, so that's that guy. Now, it's got $200 worth of collets, and I wanted to use them. So the reason why is this guy. I need to put this guy in the Spindexer because I need to make a nut out of that end here, so that this guy goes on it, and this will be the drive from the motor here. And then I'm going to make a throw out, because this just goes on the end of the lead screw on the mill. So I'll make a thing where it just engages and disengages. But to do that, I need to get that in the Spindexer, and to get that in the Spindexer, I need to use, because it's an oddball size, 5C or my collets, ER32 collets. So to do that, I bought the 1-inch, which didn't cost that much off Amazon. So I now have a 1-inch 5C, and then I bought Badoom, and the machining is nice. It was like $30 off of Amazon. So C25 ER32 150L, and it's really nice. So it goes in there beautifully. It actually had a better nut on it than the ER32 nut that's on the mill. So this is the mill one, since I'm not going to use this that much. And I put the one that was on this on there, and the reason is that this one's not very nice, is the ring should be more offset so that you can easily get a collet in there. You rock a collet in at an angle like that and snap it. This one, it's kind of all centered, and it's hard to get them in and out, so I just swapped them. Alright, well that's my, this one also too, it's weird, I'm always fighting trying to get it threaded. The other nut, boom, goes right on. I don't understand, but alright. So, those are the latest purchases. Alright, well I hope everybody enjoyed it, and see you next time.